All right, here's the final part 4, limits of rational equations. When we apply this limit, we put negative infinity into the equation, square it, it becomes positive times 5. That's huge. That's positive infinity minus 2. I'm taking the square root of a very large positive number divided by a very large negative number. And you might think at first glance that this thing goes to -1. You're super close, okay? So the top goes to infinity slightly faster than the bottom does. So it's not going to be exactly -1. Let's take a look at how the book would want us to do this problem. The book wants us to divide every single term by the highest power of x. But this is the trick question of the day. What's the highest power of x in this equation? X. Because this x squared is trapped underneath a radical, and it's not algebraically sound to just bring that out because it's a binomial. It's a technique that we use to calculate the limits for these rational radical equations. So let's divide everything through by the highest power of x and see what happens. We're going to divide 5x squared by the highest power of x, which is x. But since this is trapped underneath the square root, we divide it by x squared, and it's under the square root, and the square root of x squared is x. We divide the 2 by the square root of x squared. All over, we divide the x by the square root of x squared. We divide the 3 by the square root of x squared. So far, so good? Does anybody have any questions about this so far? This goes to 1. This is supposed to be over x, and as x goes to negative infinity, this part's gone. As x goes to negative infinity, this part's gone. And these cancel each other out. So the final answer that we get is the square root of 5. Here's the trick. This will give us the numerical value for the limit, but we have to test the nature of our final answer because we canceled a lot of things out. And again, we only have to do this for these radical problems. When you put negative infinity into it, on the top, it's going to be a positive number. But when you put negative infinity to the bottom, as is in the original, it's going to be a negative number. So we take a positive number divided by a negative number and get a negative number. Hopefully you'll be able to remember that. Let's use the Smith method on these, okay? The Smith method on these, you have to check the nature of your final answers and make sure that it's positive or negative also. The Smith method says, well, shoot, this is only going to happen like the highest power of x. It's going to look like that. And this, it's going to only behave like the highest power of x. So it's going to only behave like this. Up top now, it's algebraically sound to bring that square root of x squared out in front. Do you see what happens there? Now these x's cancel, and you're left with the square root of 5 with nowhere to plug in the original limit value. So again, you have to determine the nature of the sign before you start or before you circle your final answers, okay? When we look back at the original, we had a positive infinity divided by a negative number. A positive number divided by a negative number is a negative, okay? We'll get the numerical value right and then double check the nature of these. On this one, this is strange, and some of the problems that you will have on your Pearson or my Open Math Lab, you'll have rational equations, and sometimes the radicals on the top. They've been rationalized. Okay, this is a rare moment where we are going to want to get rid of this binomial and get rid of this radical by multiplying top and bottom by the conjugate of the top. So whether this radical binomial is on the bottom or top, you're going to multiply top and bottom by its conjugate. Okay? This is why I put this rational in quotes. This is not really a rational equation until I put it over 1. And it's kind of a cheap way of saying, yeah, it's a comparison of two numbers by division. But if we throw positive infinity in here and then add 3 and take the square root of it, you would think you'd get infinity minus infinity, which is what, 0? It's 0. So let's see what happens when we do this multiply top and bottom by the conjugate. What's the conjugate of garbage minus something? It's going to be garbage plus something. So we multiply the top and bottom by this garbage plus something. This limit just goes along for the ride. That times itself, the radicals have a way of disappearing, and you're left with x squared plus 3. That times that, plus x times the square root of x plus 3, minus x times x squared root 3, minus x squared. The middle terms drop out when you multiply by the conjugate. And now here we have that circumstance again where we have this radical in the bottom. You don't have to rationalize it as long as it has a variable under there. So far, so good. This cancels with that, and you're left with 3 over this garbage. So now we have 3 over infinity plus infinity. Now the key about this infinity plus infinity is it's going to positive infinity. Whereas up here, we didn't know which one was winning the race. Infinity minus infinity, but this one might be going to infinity a little quicker. So what we have here is infinity plus infinity, which is positive infinity, and 3 divided by positive infinity is 0. I hope this helps, guys. I know those last couple of problems get kind of peculiar. Shoot me an email if you have any questions. We'll see you in class tomorrow.